This video is brought to you by TS4U IT Engineering Bootcamp.
So I have been screening your the resume. It is great. Some of the tools and technology you have been experienced with, and we are using some of the tools very heavily in our day-to-day work and our project. We are using the Docker, Kubernetes. So without any delay, I would like to ask some questions starting with the Docker. So can you design a Dockerfile where I want my container to be lighter and do not want to run the builds every time the container is run?
Okay, yeah, well, so basically, as we know, we always use Docker files to build our Docker images, right? Which then actually runs as a Docker container. So when we build our Docker images, one thing we always try to make our images lighter, first of all. And the second of all is we always try to minimize the time to build that Docker image. Okay, so since we use a pipeline to build our Docker images, so that's why the pipeline actually runs as a different runner, and then it always counts the time that, okay, for this period the runner was run, and then based on that we are getting built. So like this is a cost related question as well as of the build times or as of the performance as well. So what we actually do is basically we build our Docker images with an optimized Dockerfile. Okay, so in our Dockerfile, we always try to do multi-stage Docker builds, which basically lets us have multiple stages in our Docker images. Where let's say, okay, in the first stage we use some sort of builder image, and from there we just build all the necessary dependencies. We build the entire project, and then from that optimized after the optimized build has been done, we basically move to a second stage where we actually take that build output only, and then we just transfer only the necessary things to the next image. So that's the multi-stage build. And since we use multi-stage builds, we basically need to choose multiple images. Okay, so let's say this is a node-based project. So in my last project, I basically worked with the Node.js as the backend, and front end was with the React.js. Okay, and some of our projects were on Python as well. So let's say for the first stage, we needed to choose usual image. Let's say this is a Python Docker image. We using Python 3.10. So that was a Python image, a usual Python image, which had maybe more than 1 GB in size. And for the node images, that was kind of same. It was maybe 970 to 1 GB of size. So we were using node 16 at that point of time. And for the front end projects, we also use the node based image, base image. So those images were not very light. Okay, so the base image was just only 1 GB in size, and then after adding the dependencies, it would cross easily 1.5 GB in size. So we couldn't have that, right? So we needed to optimize it. So on the second stage, we actually choose a lighter image. Okay, so we wanted to have the final outcome as the lightest, so not the first stage. So for the first stage, we always wanted, okay, let's see if we have everything what you need on the first image, so that we don't have to download some other dependencies from the internet, so that we can actually build the first stage. We don't need that. We deliberately used what do you call, it's a heavy image, and then that image actually had all the prerequisites to build our image, so that we don't need to increase our build time. And on the second stage, we basically choose an Alpine image. So we were using Alpine 3.13 at that point. Okay, so Alpine is a very light image. So this is just a bare bones Linux container image, which basically is 50 megabytes in size. So whenever we had all of our builds done on the first stage, and then we got our output or the build files from the first stage, we basically just copied from the main base image, and then just copied the build outputs on the second Alpine image, and then we just wrote a Docker entry point script to run that build. And this is how the final Docker image would be less than 100 megabytes in size. Okay, so that's how we always build our like lighter Docker images. And then whenever we run the builds, we always try to cache certain stages. Okay, for example, we are using the node-based projects, and for the front end, we also use React. So it's basically JavaScript, and we all know that the JavaScript has the npm as a dependency manager, right? So npm actually takes a lot of time to install dependencies. So it would maybe like whenever we run the npm install, it would go ahead and install like 10,000 or like 15,000 of dependencies, right? So it's really heavy and time consuming. So whenever we actually tried to run the builds, we had a caching mechanism where, okay, in the Dockerfile, we say that if you see any changes on the package.json file, then only you run the npm install. Otherwise, just use the cached one, because the package.json didn't change. It means no new dependencies were added. So we basically just implemented that kind of Docker layer caching that Docker like provides automatically. So we just leverage that, and this is how our build time was like down to under a minute, right? So it was taking like more than 10 minutes to build, but after we implemented the caching mechanisms, the like reusing layers of Docker, we basically had that lighter image build, and then we had the less time consuming Dockerfile build as well. Okay. So
Sure.
yeah, this is what we did in our practice. So we always try to use the best practices that
Right.
were available at the time.
So I have a follow-up questions. I actually took some notes while you were answering the questions. So of course, the DevOps team or CloudOps team always not only the responsible for the building, and we have in our environment, we have sometimes when the version came and the developer using the older version. So, the responsibility goes to the DevOps team to make sure that the latest version is being evaluated, latest version being installed and configured. So how do you deal the conflict with the developer, or just propose them, hey guys, we got the node 16 across the application, you need to update, because the developer has to update as well, and they have to do some work. So do you have any type of conflict with them? If it is, how do you solve them?
Yeah, definitely. So we always had conflicts, right? So because it's a like node-based environment, and we use the Python as well. So both of these systems actually don't have a very good package management solution. Every time there is a new package coming in, some other packages were like not building because they wanted the previous version. And sometimes the like dependencies has two kinds, right? One of the dev dependencies, another one is the production dependencies, right? So like most of the time we are having issues with the dev dependencies, because like it's running on the developer's machine, and then they just pushes their dependency in the package JSON file and the package log JSON file as well. So package log will always like force us to install whatever like that was available on the developer's machine, right? So we always had these kind of issues because different developers were like building on different package JSONs based on their like own machine. So they were just always pushing their version of like package log files in our Git repo. So as we like clone the Git repo when we build the image, so we always had these kind of issues that, okay, in our Docker file, we expected this kind of dependencies and this version of the image, and then they accidentally pushes their version of the Docker file and their version of the package log JSON. So we basically like saw that, okay, this is being changed. So whenever we try to build the pipeline, we basically tell them, hey, this is kind of wrong. Let's fix this on the next push when you like update your code base. So we basically suggest that, okay, like take whatever you have on the Git, because that is the source of truth. Like try not to like change drastically on your system. So we always want to have a like centralized thing or centralized configurations for all of our projects. So that's why we always focus on the Git as a source of truth. So that's why we always ask them to use the like whatever you have latest on the Git. Okay, so they needs to pull it, they needs to like set up their work environments like that way, and then we basically have a like, smoother experience. But time to time these dependency things always happen, so we just need to like sit with them and then find out, oh, okay, this is the like dependency that is causing the issues because this was added in the last week, so the build is failing. So what are the dependencies of this dependency, because it's kind of like a dependency hell, right? So we actually, as a DevOps, we don't know that if this package is like failing, we basically don't know most of the time that, okay, for this other dependency, this one is failing. So you always need to kind of have the meeting set up with the developers, and then we like show them that, okay, this is the log we are getting. This is where the build is failing. Can you tell me where? Okay, and then they just show like backtracks the problem and then shows us, oh, okay, this is the like main issue, this is the dependency that you need to update before installing the other one. So this is how we just like do the teamwork, and then finally it fixes, and then we just write a small review on that like issue and then post it on the Slack channel so that everybody gets updated that, okay, this is what happened, and if this happens later on, we can fix it this way.
Thank you. I think that's the good way of doing it. I think you have answered, but I want to just ask again, if something you want to add, you can add. That's again another follow-up question related to the Dockerfile. So can you explain the structure of your own Dockerfile? Of course, you write the Dockerfile or you give the developer to best practices. Why do you think best practice you follow?
Okay, so like Docker is a like kind of globally accepted way of building Docker images, right? So we know there are like so many other tools. Even the Kubernetes also teach the Docker as the default like Docker engine on the Kubernetes as well. So they are using Cryo, some uses the Rocket and all the other projects, right? We have Containerd as well. So basically, we just use Docker. So because we have been using it since the beginning of the time. So we are comfortable writing Docker files. We are comfortable having Docker in every single environment and every single like operating system that we are on. So it's kind of easily available. So choice-wise, Docker was our first choice, and then the Dockerfile, like writing Docker files is very easy. So we are always on to that. And for the best practices, we basically have some globally like accepted terms and rules that, okay, this is how you need to build your images to make builds faster, to keep your images lighter and everything. So yeah, we basically went for those things, and some actually came from our own experiences as well, because we saw that, okay, if we actually change these two steps with this entry point script or our custom script, then we can actually like what do you call, like improve this two stages better. So this would take, let's say, 1 minute, and then with our script it would be done within 10 seconds because we are optimizing it on the background. So like we kind of have best of both worlds, because like this actually came from experience. So we followed whatever we have on the internet, that okay, this is what like everybody is doing, and then based on our system is not like everybody's else, it's not going to be right. So we basically had to adjust and adapt some of our own scripts with our Docker file so that we can have a like smoother image build and maybe a lighter one and a faster one, because yeah, time is important.
Got it. Thank
Okay,
you very much.
so if I want to go through the structure, we basically have multi-stage builds for all of our images. So we have Golang as our background, we have Python as our backend, we have the Node.js as our backend, and for the front end, we basically use only React. So all of them actually has one build stage, and the second one is the like final output stage. So for all of our base images, we basically use their own version of like images for the runtime that we found in the Docker Hub. We basically use Docker Hub for the base image storage, right? So from that, for the first stage, we basically get the usual images that everybody uses. And for the second stage, or that is usually the final stage, we don't have images with more than 2 stages as of now. Okay, and we basically didn't need it. So for the second stage, we always try to use an Alpine image, and mostly like latest version of the Alpine image, because 2 years ago we basically implemented a CVE analyzing tool, or the container security tool called Trivy. Okay, so whenever we build a Docker image, we have a pipeline stage where the Trivy actually analyzes our image that has been built on the previous stage, and then it gives us some output that, okay, these are the known vulnerabilities that your Docker image is actually having right now. So most of them are actually caused based on using the older version of the dependencies. So whenever we try to update the Alpine, it basically erases those dependencies or CVEs, and then we basically have them fixed on the newer version of the base operating system. And sometimes we need to update the dependency version as well to get rid of those vulnerabilities. So Trivy actually shows us that, okay, this is the version that you're using, and that has the problem, and then this is the version that actually fixed it. So we basically have the idea that, okay, if we just upgrade this dependency into this version, then it's going to go away. So that is our best practice and the structure for the second stages of images. And then we basically use the copy arguments in a smart way, I would say, so that we can cache most of the stages of the Docker build, so that we can have a faster build. And yeah, that's pretty much it. And we use the Docker endpoint script to initialize the application, so that if we need to feed some new data into the system, if we need to run migrations on the background and the database, we basically have those scripts as an entry point script, and then we just attach that entry point script with all of our Docker images.
Thank you. I think we have answered the Docker image scanning, because in our cases we have a monitoring tools to scan each of the whatever Alpine image or an image we use. We have a situation where we have not used the official image, then that caused some harm, and then we actually across the aisle made a rules. You cannot do this. You have to go through the scanning process. Once you get the thumbs up, then you move forward. Okay, thank you.